John Houghton has in his career combined remarkable scientific achievements in the scientific, let's call it classical research field, as is testified by the number of awards and prizes he received from national bodies in the UK, international bodies. There's an impressive list, which I will not read this morning. But also, he is well known and appreciated in the scientific community for his scientific and organizational leadership. And the most famous aspect of this activity is, of course, his personal involvement in the role of the IPCC, or GIEC in French, which, as you know, under the auspices of the United Nations, produces assessment reports on climate change, which now play a very important role, not just in the scientific community, but in all aspects of the political decisions and the future of the planet. So, this aspect was also awarded by a large number of prizes, and this is a remarkable achievement, and that's why I'm really honored to introduce Professor Houghton. Maybe a not so well-known aspect of his career here in Belgium is the prominent role he played in the UK, as he was director of the Met Office, which is a key organization in climate research. He was also very active in the development of the Hadley Climate Research Center, which is now also has become a very famous and remarkable institution in the field of climate research. Now, as a space scientist myself, I'm also want to evoke his remarkable work in the field of remote sensing of the atmosphere using infrared techniques from satellites. And together with colleagues at Oxford, he founded a well-known, very famous research group now in Oxford. He has been the PI of 4 experiments on Nimbus satellites, NASA satellites, and he has developed techniques and methods to retrieve the temperature information from remote sensing instruments. And as you probably know, now this is a very well established and extensively used method to probe the Earth's atmosphere, and in the recent year it has also been extended to the exploration of planets, and missions such as Cassini or Venus Express have now remote sensing infrared instruments which operate continuously to monitor the temperature profile in not just in the Earth's atmosphere, but also in planetary atmospheres. And finally, I want to say a few words about the way I personally got in contact with John Houghton's work, which was when I started preparing lectures in the field of atmospheric physics, and I got acquainted with this book called The Physics of the Atmosphere. This is the second edition, but it has been, I think there has been in 2002 or 2003, a new edition. And this is also a remarkable small book which contains the essentials of planetary physics, and which has been used by, I'm sure, a very large number of teachers and lecturers in the world. And this is a book which is still recommended as a basic work to get used to the fundamentals of atmospheric physics. So I wanted to emphasize this aspect also. Thank you for being here and accepting to give this lecture this morning. And I think you will present your seminar, and you said you will be ready to address questions from the audience afterward.
Well, thank you very much, Jean-Claude, for that introduction. A great pleasure to be here in Liège. I think my last conference in Liège was in 1963, I think, a long time ago. But it's a great pleasure to come here again and to be here with you today. What I want to try to do is to give you a sort of bird's eye picture of the last 50 years in research in the atmosphere and in global climate in particular. And without any more ado, I'll start to move on to my slides. And there we are. That's fine. I've got it now.
This way, here.
That's fine. That's lovely. Thank you. It's been a remarkable story over the last 50 years in the atmosphere, the oceans, and the whole climate system. We've learnt so much from very small beginnings. And the revolution has occurred in this part of science because of two particular techniques: observations from space and computer modelling. And it's those two tools which we've been able to use to great effect as we've studied the whole of the system. And I remember in 1957 when the first Sputnik went up, and this small thing began to circle the Earth. And I began to realise here was potential for observing the atmosphere and observing the whole system of the Earth in a way which was completely revolutionary, because instead of just looking at little bits of information from different places at different times and trying to fit it all together, there was a possibility of doing something from a Sputnik. And I was then working at the Royal Aircraft Establishment in the UK, which was a defence research establishment. I was part of an infrared group. I was an infrared spectroscopist, but I'd been making measurements on the atmosphere, and we were at a country house outside Farnborough, because the Farnborough establishment during the war had been spread around some of the country areas to keep it away from bombing. And it was a lovely country house, and we were doing our work there, and one of my colleagues there was Desmond Smith. And we were keen young people. We loved walking and climbing and things like that. We did a lot of talking together. And we began to say, well, what could we do? How can we observe the Earth from these little balls, these new satellites, which are going to start going around the Earth and its atmosphere? We began to wonder how we could do it. And then in 1960, the Americans launched their first weather satellite. And there it is, quite a small thing with television cameras on board. And there are its first pictures on the 1st of April 1960. And those are the first pictures of clouds of the Earth from a space vehicle. But Des and I'd by then gone back to Oxford as a lecturer, and Des had gone to Reading University, which wasn't too far away. We still met quite often, and we thought, well, it's all very well looking at pictures from a camera, and that's interesting, of course, but can we measure things, measure numbers? Can we measure any quantities in the atmosphere or on the Earth's surface or so on from space? What could we measure? And how could we measure it? So, could we measure atmospheric temperature, for instance? Well, there was a paper written by a man called Lewis Kaplan, an American, Journal of the Optical Society of America, about 1959, when he said, well, the Earth is emitting radiation out to space, and that radiation comes from all sorts of, it comes from the surface, it comes from gases in the atmosphere, it comes from clouds. That radiation contains